I found on YouTube a very interesting YouTube channel. I can advise everyone to look at it. Here is the title of the video. Identify chemicals with radio frequencies. Well, he does this in a very scientific way, using, say, a pulse signal that he sends into the chemical substance, then listening to the radio frequencies that are, say, returned because they are the molecules are, say, inside. The electrons around the molecules are set to a certain position, and when they fall back, has everything to do with the spin, etc., etc. When they fall back, they give out a certain frequency. It can be measured, and it means that you can identify the chemical substance in a certain way. And he also mentions some frequencies where this simple project, in fact it's simple, but it's on the other hand very complicated what he has made. Look at the video, etc., etc. So he inspired me to do this experiment, and I'm not taking any scientific conclusions. I look at it only from the radio theory, and then we are talking about the circuit that I have made now, and it's on my workbench. So this is the YouTube channel that I want to refer to. Applied Science, his experiments are brilliant. He combines electronics knowledge, and in this case also scientific knowledge and knowledge in the chemistry field. But anyway, my idea was, when he did this, is it possible that when you have an oscillator, a radio oscillator, and with a coil, and you stick into that radio oscillator a glass tube with a certain substance, is it possible when you tune the frequency and tune the frequencies to the frequencies that he mentions in his video regarding to certain chemical substances, is it possible to see a change in the resonance peak? So this is, say, a very simple idea. I don't attach any scientific conclusions to it. I only look at it from the radio theory, and I think it's fair to say that in that case we look at the damping of the coil. So the coil here is on a resonance. We stick in a glass tube with a certain fluid, and let's look to the effects on the resonance peak. I've not made all the connections here from the scope to the wobbulator. That's what I'm using. It's a wobbulator. It sweeps in a certain frequency band, and it makes the resonance peak of the coil visible. So let's look at the differences when we put into that coil a fluid. So up to the workbench, and like I tell, it's only a very simple demo. So here are the fluids that I'm testing: water, oil, sunflower oil, red wine, and lemonade syrup that has, of course, a high sugar content, and it's not made with fake sugars, so there must be glucose inside, etc., etc. And from wine we know that there are tannins inside, etc., etc. So here is the setup. This is the tuning of the coil. Here you see The whole setup is the wobbulator that I published earlier, and I will show the schematic in the description. There will be a direct link to this wobbulator. We set here the frequency. When the red LED lights up, it's oscillating. Via the counter we can look on which frequency it is oscillating. This is the coil, and like I say in the schematic, it has 125 windings. Here you can see it very good. Here, 125. And of course the glass tube must slide in easily up and down to see the effects of the damping of the fluid. So schematic again. I have already showed it, but anyway, when you are interested in the schematic, go click on the link in the description and then you can see how I made the wobbulator. So let's see what this all can bring. The wobbulator here again. This is the resonance peak that it gives out now. This coil that is on the workbench, and it is 941,937. The oscillator is not so stable, but it doesn't matter much. I only want to show, say, a kind of principle. This is the resonance peak when nothing here is inside that coil. So the coil is completely empty, and I'm gonna stick in now at first the water. I hope that my camera doesn't drop. So this is the tube with water. Stick it in here. Let's see what happens. And like I say, I don't attach any scientific conclusions to it. So this is when the water is inside that coil. You can see that there is damping, a certain damping. And of course, when you choose the right frequency, right high frequency, put an enormous amount of energy in it, surely that water will start to boil anyway. So we have different frequencies. This is the maximum peak, 912. I take it out a little bit. Here it is 788 or so kilohertz. That's the first experiment. This is oil. Let's see what the oil does. Let's at first look at the scope, of course. When we see, say, a change in the resonance peak, no change in the resonance peak. What could be the reason? Perhaps, and it's a free thinking by me, the water has polar properties and this oil has no polar properties. Correct me if I'm wrong. Here's the red wine. Put it in here. Let's see what happens. Well, this is a kind of drama. I put in the... Now the red wine is here at the underside of the coil. So no connection to the coil. Can also be my hand effect, by the way, but anyway, I will... So here's that red wine. I think this is the hand effect. Anyway, we see kind of dip of the resonance frequency, and also we see here differences. Now the red wine is in the middle of the coil. I take it out. So there are certainly effects. This is the lemonade syrup. It contains glucose. Do it again here. Well, here we see a serious dip. And this is what I'm doing, is to this, this and this, etc., etc. So this is what you see and what you get. This is a serious dip of the resonance frequency. So I don't bind any conclusions to it, only say, I can say, and it's fair to say, that for instance this sugar syrup has an enormous effect on the frequency, and it means that the sugar syrup takes up a certain part of the energy that is, say, sent into that fluid. It absorbs energy at its maximum, and compared to the water and the oil and the wine, it is substantial. So anyway, thanks for watching. This was all. It's only a kind of not stupid experiment, but it's primitive. And like I say, I focus on the radio effects, the damping of the coil. Anyway, thanks for watching. And hear that beautiful resonance.